Welcome to Ask and Learn.
Welcome to the problem number 31.40. This is chapter 31, alternating current. In this question, we are given a LCR circuit. All the components are connected in series with an AC source. So we have inductance equals to zero point 0.4 Henry, resistance equals to 200 ohm, capacitance equals to 6 microfarad, and voltage equals to 30 volt. And we have A, B, C, and D point. So across A, B, C, D, we have some voltmeters, which I haven't drawn it here yet, but I will do it as we progress to the answer from A, B, C, and D part of this question. Although the frequencies are changing, so we have first frequency equals to 200 radian per second and omega 2 equals to 1000 radian per second. So we have to use different frequencies and find the corresponding answers of V1, V2, and V3, and V4, V5. So first we have to find the formula so that we can replace the omega with different values to find out. So we have Z equals to under root of R square plus XC minus XL whole square. This gives the impedance of the circuit. IRMS equals to VRMS over Z. VRMS equals to IRMS R. VCRMS, the voltage across capacitance, equals to IRMS XC, and VLRMS equals to IRMS XL. So this is our R, and this is VC and VL. And we know that VL, or the relation between VRMS and V, so VRMS equals to V over root 2, where V is the voltage amplitude and which is equals to 30 volt. So 30 over root 2. So this gives 21.2 volt. So let's do the part A. We have omega equals to 200 radian per second. So XL is equals to omega L. So we can use this value, which comes out to be 80 ohm. So using omega equals to 200 radian per second and L equals to zero point 0.4 Henry. So this gives us XL, and XC is equals to 1 over omega C. So this comes out to be 833 ohm. We know R, we know XL and XC. We can find out the value of the impedance. So Z comes out to be 779 ohm. So therefore IRMS equals to VRMS over Z. So putting all these values, so this comes out to be 21.2 over 779. So this comes out to be 0.0272 ampere. So looking at the V1, so let's draw the V1 now. So we have this V1. So we have V1 equals to VR RMS, which is equals to I RMS R. So putting all this value here, so IRMS equals to 0.0272 and R is over 200 ohm. So this comes out to be 5.44 volt. Now going to the V2. So V2 is equals to VL RMS, which is equals to this V2. Similarly, V3 we have V4 here, and V5 here. So this is equals to IRMS, VL, XL, sorry, yeah, XL. So this comes out to be 2.18 volt. V3 is equals to VCRMS, which is equals to IRMS, XC, which comes out to be 22.7 volt. And looking at V4, V4 reads VL minus VC, which is the voltage amplitude difference over 2. Looking at this one, so this is our V4, so this is the voltage difference. Because they are out of phase, so that means we have to use minus sign here. The minus sign because we have out of phase, which is equals to VL RMS minus VC RMS. So this comes out to be 20.5 volt. Now going to the V5. So V5 reads VRMS because that's a whole point, whole circuit. So A and B, which is the voltage applied by this one, which is equals to VRMS, which is this value 21.2 volt. So that's for our A part. Now we go to the B part. So omega is equals to 1000 radian per second. So that will change XC and XL. All other remaining formulas will be remain same. So our XL changes to 400 ohm, XC changes to 167 ohm, Z changes to 307 ohm, IRMS equals to VRMS over Z, which is equals to 21.2 over 307 ohm gives us 0.0691 ampere. So therefore V1 is equals to VR RMS, which is equals to 13.8 volt. V2 equals to VL RMS, which is equals to 27.6 volt. V3 equals to VC RMS, which is equals to 11.5 volt. V4 again, which is VL RMS minus VC minus, yeah, VC RMS. So this comes out to be V4 equals to 16.1 volt. And again V5, which is the across A and B point, which is the same VRMS, equals to 21.2 volt. So that's the answer for this question. That's all for A and B part. Thank you for watching the video.